Hi, my name is Josh Burns, and today we're going to go over a demonstration of how to use the Q-Track CO and CO2 detector. As with any instrument, before you begin using the instrument, you should make sure to calibrate your instrument. So we're going to go through how to calibrate this instrument using the zero calibration. So first you must turn the instrument on and go and press the CO button, which will be right in the center of the instrument. And you'll press and hold that for a few seconds until you see a few different displays, and it'll count down till 0. When it hits 0, you let go, and then you press the sample button. And before doing this, you should have your detector hooked up to a zero cal valve, which will be attached to a gas which has 0 concentration of CO. So then I'll hit the sample button, and it'll begin counting down from 90. Our concentration, when this is complete, should read 0. If it does not read 0, you'll need to adjust the concentrations using these arrows on the top and bottom. Alright, now that the calibration is complete, we've switched over to a known concentration of CO. Then you'll hook up the zero cal up to the known concentration of CO, and this one happens to be 35 parts per million. You should look at the monitor as it's hooked up, and it should read the same concentration as on the cylinder that you're using. You'll see this reads 35 parts per million, which is the same as the concentration on this gas, which is 35 parts per million.
Now the instrument is ready for use.
We now have the instrument properly calibrated, and we have it set on the CO2 detection mode. And right now you can see that the parts per million reads at around 530 parts per million in this room. Generally in office and school areas, the levels should read at 1,000 parts per million or less. So this range that we have here is acceptable.
So for the second demonstration, we're going to show you how to read a carbon monoxide level. So as you all might know, one of the byproducts of combustion is carbon monoxide, which displaces oxygen in the air. So we're going to light this piece of paper towel on fire, place it in this jar. We're going to seal the jar for a few seconds just to let the oxygen be displaced out of the jar, which will create a vacuum, and then the majority of the jar space will be filled with carbon monoxide. So I'm just going to
As you can see right now, we have background levels of 0 parts per million for the CO, and we're going to let this combust in here, and then afterward we'll take a reading. As you can see, levels are beginning to rapidly increase as the CO is going into the monitor.
For our next demonstration, we'll be showing you how to properly use the microwave survey meter. So first, as with anything, you want to make sure the instrument is working properly. So the first test you want to do is the battery test. So simply turn the knob to battery test, and the needle should stay above the green line. As you can see here, it is. Next, you want to do a probe test. So you simply switch the dial to probe test, and you will see it float back down in between the two green brackets that say OK. So our battery is good and our probe is good. If the probe failed, you would change the probe, and if the battery was bad, you would simply change the battery by unlatching this and putting a new battery in. So for new microwaves, no more than 5 megawatts per centimeter squared at a distance of 5 centimeters from the microwave should leak. It's obviously more of an issue with old microwaves, which you can see we have here, so we're just going to run a simple test on 3 different settings: 100 megawatts, 10 megawatts, and 2 megawatts at both a slow and fast response time. The fast response time will show you areas of higher leakage. So we have a microwave. As you can see, we have a jar full of water in here. You always want to remember to never microwave empty because it could damage the microwave. So I'm going to first turn the selector switch to 100 megawatts on a slow response, I'm going to turn the microwave on, and then I'm going to hold the cone directly up to the microwave, perpendicular to the surface of the table. My first reading says 0, so I'm going to switch to a fast response, which also says 0. I'm now going to switch to 10 megawatts, and I'm getting a 0 radiation leakage on both slow and fast response. Now at 2 megawatts, I'm also getting a 0 reading on both slow and fast response. So as far as these tests indicate, this microwave is not leaking any radiation.